Okay, this is the mock review exam solutions for non-right triangles. First they say that we have a triangle ABC, and this triangle has two known sides, 4 and 3. So let's draw the triangle. We don't really know which side is, you know, long and which side is short. We'll just label the vertices ABC for now. And then it says AB is 4 long, and AC is 3 long. I guess I'm going to adjust my drawing because one should be shorter than the other, right? And the area of the triangle is 4.5 centimeters. Now this should already give us a clue as to what equation we're going to use, because we only learned one equation having to do with the area of a triangle. But it says find the two possible values of the angle BAC. BAC would be this angle here, because if you say BAC, A would be the middle vertex, so it would be this angle. Okay, so what would be the value of that angle? And they tell us the area. So that should give you a clue that we're going to use the formula area equals 1/2 AB sine C. Okay, this tells you the area of any triangle, not just right triangles, but any triangle. So what you need to know is two sides and their included angle, which we don't know, but they gave us the opposite. They gave us the area itself. So we know what the equation equals, then we just need to find values for everything else. So like, for example, as we labeled, well, let's see, just to confuse things, the angle that we want to find is the angle A. So let's do this. We'll change that to A. And if we change this to big A, then the other two will be small b and small c, right? Because the big letter A is for the angle. The opposite side would be small a. And we not only don't know what A is, small a is, we're not interested either. So let's just like leave, we'll just change all the names here, okay? So what we do know is B and C. So we'll substitute those in. We'll put in B and C. You may put them in the wrong order, but it doesn't matter. And then the sine of A, which we don't know yet, okay? And that's all equal to 4.5, which is the area of the triangle. Now we're just going to do some algebra. So 4.5 equals 1/2 times 4 times 3 is equal to 6, and then sine A. And then we want to isolate A. So the first thing we're going to do is we're going to divide both sides by 6. We're going to get 0.75 if we divide 4.5 divided by 6. These cancel out and we get sine of A. So we get that the sine of A is 0.75. And one more hint, it says find two possible values for the angle BAC, which is actually, angle A also. Let's figure out what two angles give us a sine of 0.75. And the calculator easily gives us one of them. We just do second sine inverse, and then we give it the value 0.75, and then it will give us a value. And is this degrees or radians? Well, if you want to check to see if it's degrees or radians, you go into mode, and then you look, oh, it's in degrees, which is fine. Okay, so the answer is 48.6 degrees. That is one of the possible angles. So the angle 48.6, which looks, almost like a 45-degree angle, it gives us a sine of 0.75. So the height of this triangle is 0.75, and the hypotenuse is 1 on the unit circle. Now, what other angle would give us the same sine? Well, since it's a positive 0.75, the other angle that would give us a positive 0.75 sine would be the reflection of this angle about the y-axis. Okay, so if this angle here is 48.6, the reflection would also have an angle of 48.6 here. And then if we were going to try to say what the measure is of this angle for the green triangle, we have to measure it from this 0 line. And we could see that that is basically 180 minus 48.6, right? So whenever you take the reflection about the vertical axis, what you want to do is you want to take the angle and subtract it from 180 like that, okay? So let's find out what that is. 180 minus 48.6. And the answer is 131. So the two answers are 48.6 degrees or 131 degrees. Those are the two angles which, for these side measures, will give you a triangle that is 4.5 centimeters squared. And so like one of them is going to like look really flat like that. And one side's going to be 4 and the other side's going to be 3. And the other one's going to be a little bit, you know, a little bit narrower like that. Okay, so both of these triangles have sides 4 and 3, but and they both have the same area, which is 4.5. But you can see that there's a solution with a very wide angle and there's a solution with a narrow angle. Okay, moving on to number 2. There's a vertical tower TA of height 36 at the base A of a hill. A straight path goes up the hill from A to point U. Point U is actually like halfway up the hill here. This information is represented by the following diagram. Okay. The path makes a 4-degree angle with the horizontal. The path is this green line here. And the horizontal would be this brown line here. So the 4 degrees is right there. That's the 4-degree angle. Okay? The point U on the path is 25 away from the base of the tower. So this line here is 25. And then the top of the tower is fixed to U by a wire of length X. So there's a wire here going from U to T, and that is X long. We don't know how long it is. Complete the diagram showing clearly all the information above. That's it. Okay. Then it says to find X. Okay. So to find X, we are going to need some more information about the triangle. If we have two sides of a triangle and that's it, that doesn't help you. You need a third side, which we definitely don't know because they're asking for it, or we need some angles. Are there any angles here we can figure out? Well, let's see. We know that this angle, this orange angle here, is 4 degrees. Does that help us? Well, we know just by the fact that we drew this brown line horizontally, and we know that the the tower is vertical, we know that this is 90 degrees, right? So if we know that's 90 degrees, and we know that the orange part is 4 degrees, then whatever's left over, which is 90 minus 4, is what this angle measures, right? So this would be 86 degrees, okay? So that really helps, because now we have an angle, and we have two sides, and the angle is also an included angle, which is very important. So we got an 86-degree angle, and we got one thing which is we got one angle which is 30, one side which is 36, and we got the other side which is 25. Okay, 86 degrees. Okay, and so now what we're going to do is we're going to solve for x, which is this side here. Okay, so when you have two sides and an included angle, it so happens that you use the law of cosines. Okay, but another way you could think about without memorizing that is the fact that when you use law of cosines, basically the sides that you know or you want to know about, A, B, C, And there's one angle that you want to know or know about. So that would be, for example, angle A. So if you indicate all the sides that you know or want to know about, and all the angles that you know or want to know about, and it looks like this with one angle and three sides, that's law of cosines. One of these is going to be unknown, and it just so happens that in this problem, the unknown is the opposite side from the angle. Okay, and so let's say that this angle. Well, you could write it out in any way, but you just need to make sure. Like for example, normally it's written like this: c squared equals a squared plus b squared minus 2ab cosine of big C. But we could rewrite it as a squared a squared equals b squared plus c squared minus 2bc cosine of big A. Okay? And so the big A here would be 86 degrees because that's the only angle we're working with, right? And then BC would be 25 and 36. So this would be big A, this would be small b, this would be small c. Okay? Let's fill in everything. The thing that we don't know and what we're looking for is small a. So we'll leave a squared as a variable. B squared is going to be 36 squared. C squared is going to be 25 squared. Minus 2 times 36 times 25 times cosine of 86. And the cosine of 86 is a lot easier sometimes to just go ahead and find out what that is in numbers, so the algebra becomes easier. 0.0697. So this is 0.0698, I guess. 698. And then that's multiplied times all these other things here. And so we'll go ahead and multiply all this out offline, and then I'll give you the answer. Just finishing up, when you do the algebra, 36 squared is 1296, 25 squared is 625, 2 times 36 times 25 is 1800, and then when you multiply 1800 times 0.0698, you get 125.64. And then you just add everything up, 1296 plus 625 minus 125.64, and you get a squared equals 1795. Now you just take the square root of that and you get that a is equal to 42.4. Okay, so in the end what you find is that the line x is equal to about 42 meters, which kind of makes sense because the pole is 36 meters, and this line x kind of looks like it might be a little bit longer than that, so just from the drawing, although the drawing is not really accurate. Okay, so we'll say that x is equal to 42.4 meters. Okay. Okay, last problem. The diagram shows a vertical pole, PQ, which is supported by two wires fixed to a horizontal ground at A and B. So this is basically a horizontal pole, and this is a 3D drawing, so maybe it might be a little bit hard to understand. And it's fastened to the ground with two wires. Okay, and it's fastened to the ground at two places, point A and point B. A and B and Q are all on level ground. And there are two triangles, at least, that we're going to be looking at here. One is the ground triangle, which is this triangle here. And the other triangle is like a vertical triangle, which is this triangle here. Okay, so it's kind of like an upright triangle. And so let's see if we can figure this out. They give us several numbers here, and all of them are written on the angle that they represent. The only one that we need to write in is the first one, BQ equals 40. That one we're going to label this line BQ 40 meters. Okay, the rest of it's all labeled. How lucky that the side 40 is part of the vertical orange triangle and the horizontal red triangle, so it's very useful. Okay, first it says to find the height of the pole PQ. Let's see, what do we know about this triangle, orange triangle PQ, or the triangle with PQ in it? So there's P, Q, and B. And we do know that the horizontal part of it is 40 because they told us that. We also know that this angle here is 36 degrees because they told us that. Now we don't know the hypotenuse, and speaking of hypotenuse, we do know that this is a right triangle. Can you see the right triangle symbol there? And that makes sense because the pole is vertical. Okay, so all we know is the angle, and we know two angles. We know the 36-degree angle up here at the bottom, and we know the 90-degree angle, and we know the length of the adjacent side, hint, hint, which is 40. Okay, if I say we know the adjacent side, the hint is that we might be able to write a cosine equation from this because cosine is adjacent over hypotenuse. So we could write that the cosine of 36 is equal to 40 over the hypotenuse. But that doesn't help, does it? Because we're not even interested in the hypotenuse. What we want to know is the height of the pole. Now, could we write some other trig function which uses the opposite and the adjacent? Hey, opposite adjacent, that would be tangent. So what about the tangent of 36? That would be the opposite over the adjacent. Opposite being h, adjacent being 40. Okay? So let's see, if we want to know h, we can multiply both sides by 40. That'll give us h equals 40 times the tangent of 36. Tangent of 36, we can figure that pretty easy with the calculator. Tangent of 36 is 0.727. 40 times 0.727, which is equal to 29.1. Okay, so the height of the pole is 29.1 meters. Okay, and then they ask us about the distance between A and B. So that would be this line here. Okay, so to figure out that line there, let's draw the red triangle, which is on the ground. And the red triangle on the ground is not so easy as the last one because it is not a right triangle. It's a non-right triangle. It's got two angles that we know, 30 and 70. And if you already know two angles, guess what? You know the third angle too because the angles of a triangle add up to 180. So if you know that one's 30 and one's 70, then you know that the remaining one is 100. Right? Okay, so we already know all three angles, which is a good start. We also know that this line, BQ, is 40 long. We used that valuable information when we did the orange triangle. Now we're going to use it during the red triangle. So let's see. Now we know one side, and we know this angle, and this angle, and this angle, and we want to know AB. So what we want to know is this pink side here. Okay, and we know all the green information. Well, whenever you know a side and its opposite angle, like we do here, then that is a big clue that you're going to use law of sines. Okay? Because law of sines, remember, you write like this: A over sine A. Oops, I'm sorry. Small a over sine big A equals small b over sine big B. Okay? And here we know all the angles and we know some of the sides. So let's say, let's start labeling these. So we'll say A, B, C, and then the sides would be small c, small a, and small b. Okay? And so what we want to know is C. And what we do know is we know small a and big A. Okay, so let's color in green the things that we do know. So we know A, we know small a, we know B, and I accidentally wrote here that it's B, but it's big C actually. And we actually know big C too. Okay, so we know, and what do we want to know? We want to know small c. Okay, so looks like this part of the equation we don't need anymore. Okay, but the rest of it we're going to write. So small a would be 40. Sine of big A would be sine of 70. Small c would be just c. And big C would be 100. Sine of 100. Okay. Oh, I'm sorry. I said that 180 minus 30 minus 70 would be 100. It's actually 80, right? Right? Because like they has to add up to 100, not 200. Okay. We'll put sine of 80 there. Okay, and then to solve for small c, we would just multiply both sides by sine of 80. And so we'll have c is equal to 40 times sine of 80 over sine of 70. Okay, and so we could just use a calculator to multiply that out. We'll have 40 times sine of 80 divided by sine of 70. And the answer is 41.9. Okay, so that would be the distance between A and B. Okay, and that is the end.